Hi everybody, welcome to our next video lesson. We're on conditional probability in this lesson. We're on 12.5. And so with conditional probability, maybe you've ever heard from your parents or an authority figure or someone say something like, you can do this only under one condition, that you do something else first. Maybe your parents might say, you can hang out with your friends this weekend as long as you clean your room first. Under this condition, should you do this first, then you could do this other thing. So we can kind of use that as we go along with conditional probability. What it states here is that the probability of E2 given, this line right here means given, the fact that E1 has already happened. So E2 can happen under one condition. E1 has already happened. It might sound a little bit confusing, but it means that you choose E2 out of only E1, not the entire group. So let's take a couple example problems. What's the probability that when you have a single card chosen from a standard deck, that you draw a heart, given the fact that an ace has been drawn? So what's happening now is you're not choosing the heart out of the whole deck, you're only choosing out of this group. So I almost kind of consider it as working backwards, class. You're finding the probability of this given this. So how many aces are in the deck? There's 4 aces. So I'm not choosing out of 52 cards, there's only 4 cards. Instead of fanning out the whole deck to you, I'm only fanning out the 4 aces. Now that I know that, what's the probability of getting a heart? Well, a lot of people say 13 because there's 13 hearts. Class, is there any such probability as 13 over 4? Absolutely not. 13 over 4 is a probability that's bigger than 1. All probabilities lie between 0 and 1. So how many hearts are there if an ace has been drawn? How many hearts are aces? There's 1. So what's the probability of drawing a heart out of only the aces? It's 1/4. There is 1 heart that's an ace out of the 4 aces. So your probability is 1/4. So again, what you're doing here is the second number here is your denominator. And then this right here is going to be your numerator only from this group. So let's practice it a little bit more. How many black cards are there? There's 26 black cards, 13 spades, 13 clubs. How many of those black cards are aces? Well, there's 4 aces, but only 2 of them are black. So your probability of drawing an ace is 2 out of a total possible of 26, which is the same thing as 1/13. Your probability of drawing that ace is 1/13. So now letter C, what's the probability that you draw a 2, given the fact that a diamond is chosen? So you do this part first. Given that a diamond is chosen, you're choosing out of 13 cards because there's 13 diamonds. So now what's the probability of getting a 2 out of those 13 cards? Well, there is only 1 2 of diamonds. There are 4 2s in the deck, but once again, you're only choosing out of this group. And there are 13 cards in that group. 1 of them is being a diamond. So we have a probability of 1/13 once again. There's our answer for letter 1C. Next one, it says make a tree diagram for a gender in a family of 2 children. If you have 2 children someday, here's what could happen. Your oldest could be a boy, or your oldest could be a girl. If you have a boy first, your second one might be a boy, or your second one might be a girl. If you have a girl first, the next child could be a boy, or the next child could be a girl. Those are the only possibilities that could happen when you have 2 children. It's going to be one of those 4 possibilities. So what's the probability of, if you have 2 children, that both of them are girls? Well, there's a 1/4 probability that's going to happen, because there's 1 girl out of a total possible of 4 outcomes. So 1/4. Okay, now we're into conditional probability. Whenever you see this line right here, that means it's a condition. It's conditional probability because you're choosing this out of this group. So we always start at the right side first. You do this part first. The older child is a girl. How many outcomes is it where the older child is a girl? Well, here are your 2 possibilities when a girl is born first. It could be a girl boy or a girl girl. So there's 2 possibilities of an older child being a girl. So given that, what's the probability that both of them are girls? Well, out of these two right here, there's only one that's girl-girl. So it's one favorable outcome out of two possible outcomes. So our answer is 1/2. Okay, now for letter C. What's the probability of having two girls given that there is at least one girl? So once again, I'm going to start with this first, and this is going to be my denominator. That's my total outcomes, given that there is at least one girl. Well, here there's at least one girl, here there's at least one girl, and here there's at least one girl. There's three outcomes where there is at least one girl. Now what's the probability that both of them are girls? Once again, out of those three, out of this one, I should say this one, and this one, there is one outcome that's girl-girl. So it's 1 out of the 3. 1/3 is the correct answer for problem number 2. Okay, on to question number 3. So we're using a table again. Again, these tables are good to understand. Here we have 12 and under who like Chinese, 12 and under who don't like Chinese food. So if we add those two up together, we get 103. And then we also have the over 12. We also have the total for people who like Chinese food, 21, 12 and under, 285, 12 and older. When you add up these two, you get this number 306. And then when you add up all the numbers in here, you get a total of 500. So hopefully this table makes sense to you. Now we're going to answer the questions. What's the probability that people like Chinese food? So this one isn't a conditional probability. It's just our basic probability. The people who like Chinese food are, let's see here, where are they? Like Chinese, there's 306 people who like Chinese food. So it's 306 out of a total possible of 500. So 306 divided by 500, as a reduced fraction, you should get 153 over 250. 153 over 250. There's our answer for question 3A. For question 3B, now we get into our conditional probability. Whenever you see this line right here, it's a conditional probability. It means given. What is the probability that people like Chinese food given that they are 12 and under? So this part right here is our denominator. Given that they're 12 and under, how many people are 12 and under? 12 and under, there's 103 people that are 12 and under. So out of these 103, you're really only looking at this row right here. Out of the 103 people that are 12 and under, which ones of those do not like Chinese food? Well, the ones that, the ones that do like Chinese food. Well, there's 21 that like Chinese food out of the total 103. So it's 21 over 103. And I don't think that can be reduced at all. Your answer is 21 over 103. Class, I just want to be very clear about this because I see this on a test a lot where students do this 103, but then they see the probability that people like Chinese food, and they go down here and they say, well, there's 306 people that like Chinese food, so they put 306 divided by 103. First of all, that's impossible because that's a probability that's greater than 1. Secondly, you got to be very careful that you only choose this out of this group. So out of the 103, which ones like Chinese food? Well, it's the 21 out of the 103. So be very careful about that when you're doing your chapter test. Let's do letter C. This one's worded a little bit differently. What is the probability that a person who doesn't like Chinese food is over 12? So we almost kind of have to, if we think about this for a second, we're asking what is the probability that a person is over 12? Think about, this is the probability we want to find. What is the probability that a person is over 12? Given the fact that they don't like Chinese food. So it's kind of like if we were to write this the way our other ones are written, what is the probability that someone is over 12 given that they don't like Chinese? I hope that makes sense to everybody. You kind of have to write it in a little bit different way. What is the probability that a person who doesn't like Chinese food is over 12? We want to find the probability of people who are over 12. but only out of the people who do not like Chinese. So that's how we write this one. So as we answer the question, we answer just like we have the whole day. We write our denominator in this one being first. How many people do not like Chinese food? Don't like Chinese food? There's 194 of them. So 194 is going to be our denominator. Now that we know that, what is the probability that of those 194 that person is over 12? Well, here are the people who don't like Chinese food. So the ones that are over 12 is this 112 right here. So 112 out of a total possible of 194. 112 over 194. And that probability reduces to 56 over 97. 56 over 97. Okay, class, why don't you guys pause the video. Try letter D all on your own now that we've tried problem letter C all together. Pause the video, please, and try letter D. Okay, so you found what is the probability that a person who is under 12 likes Chinese food. That's what you want to find. Oh, sorry. What is the probability that a person likes Chinese food, given that they are under 12? So hopefully you wrote it this way. What is the probability that a person likes Chinese food, given that they are under 12? You want to find the people who like Chinese food, but only out of the group that are 12 and under. So you're choosing this probability out of this group of people. So under the 12, which people are under 12? It's the 103 are under 12. And then which people of those like Chinese food? The people who like Chinese food is the 21 over 103. 21 divided by 103. There's our answer for question 3, letter D. We will finish the rest of the notes when you get to class tomorrow. So let me know if you have any questions on conditional probability of what we've covered so far.